4, which is the carbohydrates. This includes your sugars, your starches, and your fiber. All right, so your brain's favorite fuel is glucose, which is sugar, okay? The muscles use glucose, glycogen, and fat. Glucose and glycogen provide 50% of energy, and the rest comes from fat. So fat does give you a lot of energy. What are some sources of carbs? Everybody always thinks of grains, but you could also get carbohydrates from your vegetables and fruits. So not all carbs are fattening. The problem is that Americans consume too much of the refined carbohydrates in really large quantities. So if you overconsume any of these macronutrients, they are going to be converted into fat. Okay, so the carbohydrate family, you have your monosaccharides. So again, here you're going to see terminology. So saccharides means carbohydrate or sugar. So monosaccharides are your single sugar. This is your glucose, fructose, and galactose. Your disaccharides are the pairs of monosaccharides. So two monosaccharides come together and they form maltose, sucrose, and lactose. And then your polysaccharides are chains of monosaccharides together, and this is what forms your glycogen, starches, and fibers. And then you have your simple and complex carbs. A lot of people don't understand what I mean by simple and complex carbs. So your mono are your monosaccharides and your disaccharides are your simple, and any of your polysaccharides are complex. All right, so atoms and their bonds. This is one thing that you're going to have to know in order to understand how your body breaks down your macronutrients. So each atom has to have a characteristic number of bonds. So for example, hydrogen requires 1, oxygen requires 2, nitrogen requires 3, and carbon requires 4 to be happy. So here's an example. Let me get my little pen. All right. So here, this carbon, as you can tell, has 1, 2, 3, and 4. So sharing these bonds does give you the bonds required. So not only does this carbon have 4, but also the bond that it has with hydrogen helps with the hydrogen bond. Okay, so this is how the bonds work. And then here you have oxygen, and from up here, oxygen is supposed to have 2. So you have 1 here and 1 here. Okay. All right, so like I said, you have 3 monosaccharides. They have the same numbers and kinds of atoms. They just have a different arrangement and they differ in sweetness. Glucose is your blood sugar, and glucose has to be part of every single disaccharide. So your 3 disaccharides are either glucose plus fructose, glucose plus galactose, or glucose and glucose. Then comes fructose. Fruit, think of fruits. And it's found in fruits and honeys, and this is the sweetest of the sugars. And then you have galactose that is found in very few foods, such as milk. So this is the chemical structure of glucose. So this is the complete structure. This is a simplified structure and even a more simplified structure. So according to biochemistry and organic chemistry, when you don't see carbon but you see this connection here, you're automatically supposed to assume that that is a carbon. And they take it a step further. Because hydrogen is very common, just like carbon, you don't even need to draw it. So here, you're supposed to automatically assume that this is a hydrogen, where there's a space right there. And then even though there's no C, you're supposed to know that this little link, this juncture right here, is carbon. So all these these 2 are identical to this one, where you actually see the carbon and see the hydrogen. All right, so these are your monosaccharides. Like I said, they have the exact same number of atoms, but their structure is different. So here you can see, let me get my pen again. Here you can see in fructose, the main difference is that it is a pentagon, so it has 5, okay, and then the oxygen here. Glucose and galactose actually have the identical structure. The only difference is where this group is pointing. So in glucose is pointing down, and in galactose is pointing up. And yes, that little difference right there does make it two completely different molecules. All right, so now let's talk about your disaccharides. These are pairs of monosaccharides. So your maltose is 2 glucose units, your sucrose is glucose and fructose, and your lactose is galactose and glucose. So how do you make disaccharides and polysaccharides? Well, you want to link two monosaccharides together, and this is done through condensation. So you're linking two monosaccharides together through condensation, and because it's condensation, you're always going to have water as a byproduct. And then how do you break a disaccharide into two monosaccharides? Well, that's when you use hydrolysis. And from before, we know that hydro means water, lysis means to break. So you use water to break them apart. So let me show you what is going on here. Let's actually do it in green. Okay, so this is how you link. So up here is your condensation. So it grabs this hydrogen, this oxygen and hydrogen, and they link up together to form water, or H2O. So when they link up, what happens? This leftover oxygen links up with this carbon right here. So it forms this bond in between them. Okay, so this is condensation. This is maltose. 2 glucose units come together through condensation to form maltose. And in condensation, you always have water as a byproduct. Now, how do you break these apart? Well, you add water. So here's the water. And this is the bond right here that is broken. So water comes in here, breaks this bond, and they separate. And here you have the hydrogen, one of the hydrogens from water, and then you have the other hydrogen and the oxygen. And this is hydrolysis, using water to break things apart. All right, so now you have your polysaccharides. An example will be glycogen. What is glycogen? Glycogen is the storage form of glucose in the body. And this is not found in plants. Found in plants, it's starch. Starch is the storage form of glucose in plants. So obviously this is going to come from plants, and grains are the richest food source of starch. So this is what glycogen looks like, and every little how do you say, like blue dot, every little blue dot, for example, is a glucose. So they're just linked together continuously. So that's what glycogen looks like. So you have hundreds of glucose in this chain. And then this is starch, okay? And starch, same thing, a bunch of glucose linked together. Both of these are starch, okay? All right, so let's talk about fibers. Fibers are the structural parts of the plant. It's what makes them strong, it's what makes them stiff. So how do they differ from starches? Well, enzymes can't break down the bonds between monosaccharides, okay? So in other words, you can digest fiber. Now, fiber is further divided into 2 types of fibers. You have soluble fibers and insoluble fibers. Soluble fibers are your oats, barley, legumes, and citrus. And this type of fiber protects against heart disease and diabetes, and it lowers blood cholesterol and glucose. This is how it does it. It protects against these 2 diseases by lowering your blood glucose and cholesterol. Your insoluble fibers are your whole grains and vegetables. And these guys are the ones that promote bowel movements and exercise your intestinal muscles. So they prevent diverticular disease. So these are the bonds of starch and cellulose compared. They're just slightly different, but this difference, this makes a big difference between them, okay? But you don't have to know this. All right, so carbohydrate digestion, the ultimate goal is to break it down into glucose for absorption and use. So like I said, how do you do this? Well, through hydrolysis via enzymes. And remember that carbohydrate digestion starts in the mouth. So you have amylase in the mouth that hydrolyzes starch, okay? In the stomach, you have stomach acid and protein-digested enzymes that actually inactivate this amylase. So carbohydrate digestion stops in the stomach. And the fiber that hits in the stomach, remember fiber is not digestible, so it increases your satiety. Satiety is like feeling full after a meal. All right, in your small intestine, this is where most carbohydrate digestion happens. You have the pancreatic amylase that breaks down your polysaccharides. And then you have specific disaccharide enzymes. So maltase is going to break down maltose into two monosaccharides, which are your glucose. Sucrase is going to break down sucrose to one glucose and one fructose. And lactase is going to break down lactose, which is one glucose and one galactose. In your large intestine, the fibers is what most of the action happens. It attracts water and is fermented by bacteria, so it helps with stool consistency and it feeds your good bacteria. So this is a breakdown of carbohydrate digestion. All right, so carbohydrate absorption. You have active transport. Remember the active transport we talked about? This applies to your glucose and galactose. And then you have facilitated diffusion, and this goes for fructose. Now remember that I said glucose is the favorite food source of your brain and sometimes of your muscles. So the liver actually metabolizes fructose and galactose and converts it into glucose. So here's your small intestine. Remember your villi, which are these guys right here. And your glucose, galactose, and fructose are going to go into your bloodstream. And remember, when it goes into the bloodstream, it goes to the liver first. Okay? So in the liver, it's going to get your fructose and your galactose. Well, the liver is going to get your fructose and your galactose and metabolize it into glucose because that is the favorite food source of your central nervous system. All right, so lactase intolerance. You have lactase activity is highest immediately after birth. Why? Well, when a newborn, the only source of nutrient is milk, and milk has high lactose. So obviously you're going to have the highest lactase activity right after birth. And as you get older, because humans are not supposed to be drinking milk into their adult years, it starts to decline with age. So you could develop lactose intolerance the older you get. Symptoms of intolerance include abdominal discomfort, bloating, and diarrhea. Causes of intolerance besides age, you could have damaged intestinal villi, and this could be due through an infection or some medication that you're taking. Prevalence, this is also genetically determined. So if it runs in your family, you probably could get it. All right, so for lactose intolerance, you want dietary changes. You want to manage dairy consumption to 6 grams of lactose. Your GI bacteria do help with this intolerance, so you want to consume probiotic. Some fermented milk products, because they have probiotics, such as yogurt and kefir, do help out. And then you have individualized diets, because everybody has a different degree of lactose intolerance. Potential nutrient deficiencies, if you completely have to take dairy out of your system or out of your diet, is riboflavin, vitamin D, and calcium. So from here, what you need to know is pretty much which one has the most lactose and which one has the least, okay? So from the top is the least, all the way to the bottom is the most. So just so you have an idea of what is going on when you consume these food and how much lactose it has. Unless it says lactose free, because I have seen cream cheese and cottage cheese say lactose free. All right, so carbohydrate metabolism. Glucose is key. Remember, glucose is energy, okay? Storing glucose as glycogen, the liver stores 1/3. And how does this happen? Well, through condensation, glucose gets linked up together to form glycogen. And then hydrolysis is needed to release this glucose when it's needed, okay? The rest of your glycogen is in your muscle. 2/3 is in your muscle. It hoards glycogen. Why? Because that your muscles is what makes you move, what makes you get around, so you need access to this immediately. And then you have a very small amount in the brain that's negligible. All right, carbohydrate metabolism. Glucose for energy. It fuels most of the body cells. So it's very important. That's the preferred fuel source. So it's a preferred fuel source for the brain, the nerve cells, and developing red blood cells. Okay. Then the cells break down glucose even further, which we're going to look at in chapter 7 and 8, and how it makes and how they make energy. So, making glucose from body proteins. Okay, so primarily it's in the liver and skeletal muscles when this happens. So when this happens, it's called gluconeogenesis, which means gluco means glucose, neo means new, and genesis means to create. So this is when your body uses proteins to create glucose. You don't want this. When your body is using its body proteins to make glucose, guess what's happening? It's actually eating itself. It's digesting body proteins. So in order to avoid this, you want to eat carbohydrates. Okay? Carbs prevent this. All right, so what happens? You get these ketone bodies from fat fragments. Okay? This usually happens when there's inadequate supply of carbohydrates. So you get this your fat metabolism shifts. So when you have these ketone body formation, it's combined fat fragments and is used in starvation. So you start seeing these ketone bodies when it's during starvation. This then leads to ketosis, which disturbs your acid-base balance, which we'll talk about a couple of chapters later. So you can see how delicate this acid-base balance is. Carbohydrate is needed for protein sparing and to prevent ketosis. So yes, you have to consume carbs. I am not a fan of the low-carb, high-protein diet because even if you consume high proteins, your body is not going to spare your body proteins if you have low-carb intake. So it is recommended between 50 to 100 grams per day of carbohydrates. So the consistency of blood glucose. You always want a steady supply in the bloodstream. Okay? Where are you going to get this steady supply of glucose? Well, from food, you're going to get it obviously from the intestine. That's where it's going to be absorbed. And you're also going to get it from glycogen, your stored glucose, and you're going to get it from the liver. Okay? The liver is the one that stores the glycogen, or part of it, 1/3. So blood glucose homeostasis. This has a lot to do with your hormones. So insulin from your pancreas is one. What does insulin do? Insulin has two jobs. It gets glucose from the blood into the cells, and when you have excess glucose, it stores it as glycogen. Okay? Then you have glucagon from the pancreas and epinephrine from the adrenal glands, which brings the glucose out from storage. So it brings the glucose out from the glycogen storage. So this is what goes on, okay? When a person eats, blood glucose rises, right? Obviously, because we just ate it. So when blood glucose rises, we're here, number one. When blood glucose rises, it stimulates the pancreas to release insulin into the bloodstream. So once the insulin goes into the bloodstream, it stimulates the uptake of glucose into the cells and storage as glycogen in the liver and muscle cells. So this continues over and over and over until, here number 4, there is a decline in blood glucose levels. Why? Because we're not eating constantly, so obviously we're going to get a decline in blood glucose levels. So when our blood glucose levels gets too low, what happens? It triggers the pancreas again to release glucagon. And what does glucagon do? Glucagon stimulates here the liver cells to break down glycogen and release glucose into the blood. So the reason this happens is because the body always wants to be in balance. It always wants a steady supply of blood glucose. Okay? All right, so balancing within the normal range. You want balanced meals at regular intervals, especially if you're already pre-diabetic. Okay? When it comes to diabetes, what happens is insulin is either inadequate or ineffective. There's two types of diabetes, which we'll get into detail a couple chapters later. Type 1 is when the pancreas fails to produce insulin. Type 2 is when the cells fail to respond to insulin. And type 2 is the common one. Then you get hypoglycemia. This is most common in poorly managed diabetes, okay, or low blood sugar. All right, so here you have a glycemic response and glycemic index. So know the difference between them, okay? The glycemic response is the speed of glucose absorption, level of blood glucose, and return to normal glucose levels. So in other words, how quickly does your glucose get absorbed, and how does it affect the level of blood glucose and then return to normal glucose levels? So this is homeostasis. And you always want a low glycemic response. Why? You don't want spikes in your blood sugar. You don't want it to spike up real high and then spike down real low. You want to have a nice, constant, normal glucose level. So your low glycemic response is desired, and the high glycemic response is the one that is not desired. Now, the glycemic index is the food's potential of raising blood sugar, okay? So what are the benefits and utility for this? Well, for people that are diabetic or people that have an issue with blood sugar, it's a way of picking food that is not going to affect their glycemic response as bad, okay? All right, health effects of sugars. It's pleasure in moderate amounts. Eating sugar makes us happy. But it's also part of the obesity and chronic disease epidemic that we're seeing right now. And then it leads to nutrient deficiencies. Why? Sugar is just energy with very few other nutrients. So it counts as discretionary calories. Honey also counts as sugar because you get more energy per spoonful than regular sugar, so more calories, but it has more health effects. For example, it has antimicrobial effects. So honey is actually pretty healthy for you. But if you're diabetic, you have to be careful. It's still going to spike your blood sugar. All right, another problem with too much sugar is dental caries. What happens? The bacteria ferments the sugar in your mouth and they produce acid. And then this acid starts to eat away at your tooth enamel, okay? Food factors associated with tooth decay, time of food in mouth, so how long does the food stay in your mouth? If it's sticky food actually stays longer in the mouth. Think of when you do a gummy bear or something and a couple of minutes after you're done eating it, you're like, oh, you find like a little piece stuck somewhere, okay? And also the frequency of sugar consumption. A note to the parents out there, you're doing a child a disservice if you're allowing them to fall asleep with a bottle in their mouth. If you do that, you're going to spend thousands of dollars in pediatric dentists to fix all the dental caries, okay? Another health effects, well, for what causes dental caries is food choices. Obviously, the sweeter, such as Coke, is going to eat away at your tooth enamel, increasing the risk of dental caries. So this is pretty much what a carie is. It's just a hole. So it eats through the enamel and then it reaches the dentin. If it gets bad enough, it'll actually reach the pulp. Once it reaches the pulp, that's where you require a root canal because then you get all this here infected. All right, dietary guidelines. Reduce the intakes of calories from added sugar. The DRI, when it comes to added sugar, should be no more than 25% of the day's total energy. I personally think that's complete BS. It should be less than 10% of your total energy. I actually go with the WHO or the World Health Organization recommendations of less than 10% of your total energy. We don't need that much added sugar. All right, artificial sweeteners. You have non-nutritive, they're non-nutritive sweeteners, and in large doses, they can have adverse effects. So when people ask me, what do you prefer, artificial sweeteners or sugar? I'm like, just do sugar. If you're already gonna be sweetening something, then obviously it means that you're gonna eat something unhealthy. So just use regular sugar. Then you have stevia. Stevia is an herbal product. It actually comes from an herb. It's under the GRAS list, and GRAS stands for generally recognized as safe. Now, the problem with stevia for some people like myself is that it is sweet, it's very sweet, but it has a very bitter aftertaste, so I don't like it. Then you have agave, that's supposed to say plant, P-L-A-N-T. It's a plant product. Agave comes from the agave plant where we get our tequila from, okay? And then you have, and it's low glycemic index. And then you have your sugar alcohols, but these guys still provide calories, but they have a low glycemic response. All right, health effects of starch and fibers. So when it comes to heart disease, whole grains, legumes, vegetables, and fruits actually lower your blood pressure, improve your blood lipids, and reduce inflammation. Diet composition for reducing heart disease risk. You want high fiber, you want vegetable protein and phytochemicals, and you want a low intake of animal fat and cholesterol. For diabetes, you want high fiber foods because high fiber actually slows the glucose absorption. It doesn't just allow it to go straight into the bloodstream. For your GI health, you want high fiber foods and ample fluids. And for weight management, again, you want high fiber foods and whole grains because it's going to increase the feeling of fullness. Fiber gives you satiety. All right, and then cancer. Dietary fiber protects against colon cancer. And a lot of people ask me, well, how about fiber supplements? Well, I'm not a big fan of fiber supplements because when you get your fiber from supplements, they lack nutrients and phytochemicals. That's why I'm like, it's better to get your fiber from plants because not only are you getting the fiber, you're getting the vitamins, the minerals, and the phytochemicals from those plants. And these phytochemicals actually help protect against cancer, okay? Preventing colon cancer fibers. So preventing colon cancer, what do fibers do? They dilute, they bind, and they actually remove potential carcinogens. In addition to that, bacterial fermentation. The bacteria or the fermenting of the fiber by the bacteria actually has a protective effect. All right, so there's such a thing as excessive fiber. So be careful. If you do too much fiber, you're going to have insufficient energy and nutrient needs. You're going to get abdominal discomfort, gas, diarrhea, or it could go the other way. You could get a GI obstruction and be extremely constipated. And it's going to slow down the nutrient absorption. So like anything else, dietary goals, you want balance, moderation, and variety. If you're going from a low fiber to a high fiber diet, gradual change is key, not ket, key. Sorry for the misspellings. So you have to go slowly. You can't just go from low fiber to high fiber in one day because your digestive system is not going to like you. All right, so here are some characteristics, sources, and health effects of different fibers. You have your soluble, more fermentable, and then you have your insoluble, less fermentable if you want to go ahead and read through it. This has good information about that in your health. All right, so recommended intakes of starch and fiber. The DRI for carbohydrates is 45 to 65% of your energy should come from carbs. The RDA is 130 grams per day. For fiber, the DRI, the bottom one, or the middle one, is 14 grams per 1,000 calories, and there's no upper limit. This is fiber in selected foods. So whole grain products provide about 1 to 2 grams of fiber per serving. Vegetables actually contain 2 to 3 grams of fiber per serving. Your fruit is about 2 grams of fiber per serving. And your legumes give you a bunch of fiber. Your legumes give you 6 to 8 grams of fiber per serving. This is why they're so important. All right, so from guidelines to groceries. Whole grains, 1 ounce gives you about 15 grams of carbs. When it comes to vegetables, we divide it into starchy and non-starchy vegetables. Your starchy vegetables gives you 14 grams of carbs per half a cup, while your non-starchy gives you 5 grams of carb for half a cup. This is why it's important to overconsume your non-starchy and to limit yourself to starchy vegetables. Fruits, you get 12 grams per serving. Milk products, you get 12 grams per serving, and cheeses contain little carbs. And then in protein foods, you get 20 grams per half a cup of legumes. Okay, so you do get a lot of carbs, but healthy carbs in legumes. Legumes are excellent. They also give you a lot of protein. So when you read food labels, it's going to give you the total carbohydrate. What does this include? Total carbs includes starch, fibers, and sugars. But by law, they have to separately state how much sugar, and this includes both added and natural, and also how many fibers, but they don't usually state the starch. So how can you find the starch? Well, you get total carbs, you subtract sugar, and you subtract fiber, and then what's left over are your starches. All right, so this is where you have to start comparing labels. So there's an example, okay? So let me get my little pen again. And here you're going to see this one has 2 grams, this one has less than 1 gram, and this one has 3 grams, okay? And this all has to do with what is in there. So, if you go here, this is 100% because it says whole wheat up here. It says whole wheat and it says whole grain, okay? So we already discussed what the difference is. So in the ingredients list, it actually says 100% whole wheat flour. So that includes the bran, which has fiber in it. So it's going to have 2 grams of fiber, okay? Then here, this is just regular wheat bran. So this is regular wheat flour. It's not whole grain. So of course it's going to contain way less grams right in here, less than 1 gram, okay? And then here, this is multi-fiber low carb, all right? So multi-fiber means it comes from different sources. But just because it says multi-fiber low carb or multi-grain doesn't mean that it is whole grain. But now you're wondering, why does this one have 3 while this one only has 2 grams and this is whole grain? Well, if you look here, it includes cellulose. Remember, cellulose is a type of fiber. And it also includes these other fiber-rich, plant sources to give you fiber. Same thing with barley and cracked wheat, okay? So of all of these, which one is the best in fiber? This one. Now, if they had a 4th choice that said multi-grain, but it's also whole grain, that would be even better, because not only are you getting the benefits of having multi-grain in there and multi-fiber, but you also get the benefits of it being whole grain. So that's why I would have a 4th option in there. All right, carbs, calories, and controversies. So, obesity and the link to carbs. Total daily energy intakes have increased in the population, in the American population. At the same time, activity levels have declined. And this obviously has this has caused an increase in body weight. So, epidemiological studies show an inverse relationship between carbs and weight. All right, so meaning too much carbs, you see an increase in weight, okay? So weight loss is not just limiting your carbs, it's also watching your calorie intake. But a calorie is not a calorie. Like if you're gonna eat an apple versus drinking apple juice, and you have the same amount of calories in both, the best one is gonna be just to eat the apple because of the fiber in it. All right, so these are energy nutrients over time, and this is what is happening in our society. So here you see the blue, the carbs. You see from the 1970s to the 1990s, there's been this increase, okay, of carb intake. And then it kind of lowered a little bit in the 2000s. You've also seen a slight decrease in fat from the 70s to today. Why? Because around this time, around the 70s, is when they found the link between the consumption of fat and heart disease. So everything was all of a sudden low fat. And then protein has stayed a little bit the same, maybe a bit of a decrease right here, okay? All right, so here is your daily energy intake and increases in adult body weight over time. So again, you have seen from the 70s, the intake of calories went down a little bit to the 80s, and then they shut up. Sorry about that. In the 1990s, and they kept on increasing into the 2000s, and then there was a sharp decline, okay? But as you've seen, as calorie intake has gone up, so has body weight. This down here is women. So women have actually increased and they plateaued a little bit, and men just continue to increase too. Okay, so we're consuming a lot of calories and we're starting to consume a lot of carbs. And the thing is, most of the carbs that we get is from refined carbs. So increase in consumption of added sugar, there's another issue. You start getting high fructose corn syrup. It's very cheap. and your body is going to start storing excess sugar as fat. So carbohydrate cravings, you have these self-imposed labels of food, good or bad carbs. Why? Because we know the bad carbs are just that. They just give you empty calories and very little nutrition. So when it comes to carbohydrate addictions, it says not physiological or pharmacological, but new studies have shown that sugar can be addictive. And we'll see that in a documentary. All right, so appetite control. Some people use fructose. They think of fructose and insulin. So the problem with this is that they think it's just pure fructose may be a solution, but it's not. Reason being, even if you have these artificial sweeteners, for example, your body still has sweet receptors in your mouth. So even if it's not something that's going to spike your blood glucose, it's still going to trigger somewhat of an insulin release because your body's already tasting something sweet and it's already preparing itself, okay? When it comes to food form, liquid or solid, the more simple it is to swallow, the worse it is. So think of how quickly you go through a shake versus eating a fruit, okay? So that is a huge problem. All right, incidence response. So insulin resistance is very common in obesity. Insulin response improves with weight loss. So if you're already diabetic and you start losing weight, your insulin response will improve to the point that your doctor may reduce your medication or completely take you off it. So glycemic index and body weight. There's been mixed results, but in general, low glycemic index diets seem to curb appetite and limit energy intake of the next meal. Overweight people lose more weight in low glycemic index diets than they do in a typical low-fat, portion-controlled weight loss diet. So in other words, you do not have to starve yourself, you just have to eat smartly. All right, and that is it.